And with that, we go to the next talk from Xinyang, associated with the Jiao University and the King's College in London. And his talk will be on space-based solar power, which is a topic I did not have on my radar yet. So I'm very excited for your talk.
Okay, first of all, I'd like to thank the organizing team and also the PyPSA community for putting together such a wonderful user meeting. And it's really my great honor to be here, learning from so many impressive projects developed by PyPSA and have the opportunity to share my own work in front of you. And today I'd like to introduce one of my recent work based on PyPSA Euro named Assess Space-Based Solar Power for European Scale Power System Decarbonization. Firstly, I'd like to introduce the background and the motivation of our research. As we all know, more and more countries and regions have set net zero targets, and that means in the future, more and more fossil fuels will be replaced by low carbon resources such as wind and solar. However, these resources will be easily affected by weather conditions and day and night cycles, which will bring lots of challenges to power system stability and reliability. In this context, the space-based solar power was proposed to address these challenges because it has the potential to provide it plenty of electricity to the ground station continuously, and more importantly, one satellite can transfer energy to the Earth's multiple regions simultaneously. In our work, we have chosen two representative designs of SBSP, RD1 and RD2. Our method can be divided into three steps. And the first step is for SBSP modeling, is that we use lots of input data such as solar variation and energy transfer parameters to generate the generation profile and the generation cost. And the next step, you may be very familiar with that, is to use PEPSA Euro to establish an energy system for Europe. And the input data contains the cost and demand and weather data and lots of parameters related to the power systems. And the last step is that we combine the SBSP with PEPSA. And how we did is that we set RD1 and RD2 as two new generators to the every node of the Europe region and to do the optimization and get the result. This page shows some of the data source from our research, and more importantly is that how we get the result of the generation profile and generation cost. Um, Take RD1 as an example. We use a tool in Python named Skyfield to calculate the distance variation between the sun and the SBSP satellite and use the energy transfer parameters to calculate the power output hourly data and to compare it with the solar PV on the Earth. And for the generation cost, we have divided the process into five stages, such as launch, assemble, operation, and maintenance and disposal, and then convert the unit with the same as the same with the PEPSA, such as capital cost and marginal cost. And next is our research scenario setting. We have defined three market opportunity scenario classes for RD1 and RD2. Take the low row as an example. At this row, all of the technology will at their lowest capital cost assumption in 2050. And that means SBSP will not be easily used in this scenario compared with the medium and the high. So this means that it will have low market opportunity. And next is our result. The first result is related to the weekly output variation of SPSP and other renewables, such as solar, wind, and hydropower. The first line is for RD1 and the second line is for RD2. And we can see from the picture, RD2 will not be used in the system because of its higher capital cost. And for RD1, it's cheaper, so it will be used. And from the first line, we can get three very important conclusions. And the first one is that SPSP has the potential to provide a very large scale of electricity compared with other renewables. And the second one, we can see there is a variable that's named the range between minimum and maximums. And also the fluctuation is very small. So we can see that SPSP is more stable. And the third one is lots of the renewable power outputs will be replaced by SPSP, and also it helps to reduce the stress of the other renewables. And then we did lots of sensitivity analysis. That means we keep other parameters unchanged and only change the capital cost of RD1 or RD2 from 450 to 100, and to say what will happen to the energy system at different capital cost value of SPSP, and also the relationship between the installed capacity with the cost. And from take the picture A as example, we can see that when the capital cost of RD1 decreased to the 14 times as solar PV on the Earth, it will transfer to a complementary role. That is, it helps the renewables to generate electricity, and then if it decreased to 8 times as solar PV, it will transfer to a competitive role. That means it has the largest installed capacity. And also we have showed the electricity supply in response to SPSP capital cost in 2050. And we can see that as we is the same with our expectation, but there is a very interesting phenomenon that for the storage. And the trend of the storage is totally different for RD1 and RD2. And the reason is below these two pictures. This is the hourly power output curve for RD1 and RD2, and we can see that the variation of RD2 is higher than RD1, so lead to the more usage of the storage in the system. And next is the total cost is really wonderful, and because SPSP has the potential to reduce the total cost in the future of generating electricity. And the last result is the regional impact, and we can see the SPSP's distribution, and also it has the potential to reduce the transmission across different countries that make different countries be more independent. And the third one, we can see it changes the storage distributions in Europe. And to do the summary, and the first one is that it is the first research to integrate SPSP into an energy system model, and also we use the PyPSA Euro, and we can see its interaction with different renewables and storage and transmission infrastructures. And also we qualified the variation and comparison with different wind and solar. And the last one, I think the most important one, is that we used the sensitivity analysis, provided guidance to policymakers and to tell them at which cost could SPSP become competitive or complementary. Yeah. And that's all. And if you are interested in our work, please click the link and to see our preprint. And I'm very happy to share that today we have received the email that our work is accepted to the drawer. And if you have any questions, please feel free to ask me. Thank you.
Thanks a lot. There's one question in the chat.
Yeah. Yeah, it is available at every node of the region, and in our work, I can show you the picture. In our work, we have 37 nodes, and every node have a SBSP, a generator. That means that every place had a ground station of SBSP. And why it is so flat? Because we choose the um, daily average value. Yeah, because if you choose the hourly value, it is not easy to see in the picture. Yeah. Yeah, it's a very good question, and this is a limitation that how many stations and how many ground station, and also where to put the station. And this is another research and following our current research. In our research, mainly talk about the feasibility and some not very deployment ideas. Yeah. As next, where we will focus on the SBSP's deployment and optimize the uh, uh, how to say the how to where to put it. Yeah. Yeah, I have noticed lots of the companies are working on the SBSP, and they have provided lots of the details such as the is this safe um, for the human beings, or whether it is easily be attacked by the other countries. That's it. I think this is a very good topic, and also these companies have given some answers. Yeah, and the technology readiness is for RD1 is 4 to 5, and for RD2 is 5 to 6. Yeah, because RD2 is more easily to be realized. Yeah, you are right. And in our research, we are choosing the 37 ground stations, and the cost will change very much if we have lots of the ground stations. And also, how many SBSP will be launched in space is really a good topic. Yeah, thanks so much. And if you have any additional questions, please feel free to ask me via email, and more collaboration. I'm very open to lots of the collaborations. Yeah, thank you so much.